All right, welcome to class 15 of FOP. Yesterday we finished off the day with recursion. We had one more assignment before we were gonna call it, but we had like two students in class yesterday, and then uh we cut a little bit short. But we're gonna kick off the class for the day and pick up from where we left off. So the call stack. Can you guys see my screen? Am I sharing? Awesome. So when returning the recursive function, the multiple copies of the function will be active at once, but only the most recent one will be executing. All right, the others are paused while waiting for a result. Right. So you guys remember yesterday the pancake description. Right. The first time that call stack is made is that first stack, and then that recursive call opens up another function, but that initial one is still open, right? And that doesn't get completed or close out until the callback, right? So once it finally reaches the condition set in the callback, then all those start closing up from most recent to the oldest, which is the initial one. And then if the base case is never essentially reached, then you get what is known as your stack overflow. As mentioned yesterday, you would think recursion is nice and can actually speed up your code. It actually tends to sometimes make it longer than it would if you just used a simple for loop. It can overcomplicate some things sometimes. So as eloquent as it might look, it's not your save all for everything. So many people don't like to use recursion too much. For one, it's confusing as it is, especially if you're trying to read and see what it's doing. So people don't use recursion as much. So if you did not get it or feel as comfortable as you would like with recursion, don't sweat it. There's other material out there to help you learn it. The Grokk's algorithm book that I dropped in the FOP channel. Daniel, are you in the FOP channel or were you in the pre-work channel?
Oh, I'm in the FOP channel.
Okay, cool. Yeah, that Grokk's algorithm book is an amazing book for getting spun up on data structures and data algorithms, just basic problem solving methods to assist you with uh, dealing with data structures. So just check that out for recursion, and it will show you with nice pictures of rats. Pretty cool. All right, so the Python tutor walkthrough, we're not gonna do this, so don't worry about it. But here's gonna be the next time that we're gonna kick off this class with. It's gonna be the recursive mode.py. We'll take the next 15 minutes doing it, and then we'll cover it real quick. So the question asks to write a recursive function named multiply that takes two positive integers as parameters and returns the product of those two numbers. Right, the result from multiplying them together. Your program should not use any multiplication. You should find the result by using addition to get your thinking on the right track. Was this example, right? 7 times 4, it should be 7, right? And then plus the recursive call, and the second parameter that was going to be passed should be slightly lower. And the next call should have taken in 7 again, call the call function itself with a lower parameter for the b parameter, and so on and so forth. It should have given you something like this, right? Where you take in a and b, and you set a base call where whenever b is equal to 1, you return a, right? And a was so you can actually do the multiplication part of it, right? Else you return a plus then the call itself, where you manipulate that second parameter and subtract 1 from it. If done correctly, it should look something like this, right? The first time we multiply it, the initial first call that we make, we do 7 plus multiply, and then we actually lower that second parameter by 1, right? And it keeps doing that till it gets to 1, right? By the third call, when this returns, right, we said when b is equal to 1, we're going to return a. So this returns 7. I'm sorry. Yeah, it returns 7 because a never changed. The one that we did change was b. Therefore, Adding 7 to 7, it goes back to the second call. This function returns the 7 plus 7 that we did in the third call, adds it to that third 7. It goes back to the very first initial call we made, where we already added 7 3 times, returns it here, and adds the 7 the fourth time, right? And that's kind of how it looks like, kind of drawn out a little bit. Hopefully this helps you visualize it a little bit more than just code, right? Every time this returns, it's returning the sum that we did in the third call, and then back to the second, up to the first call, right? Therefore, adding it 4 different times. Hope you guys got this as well.
Could you show the solution code again? I got it, but I keep returning 1 greater than what I should be. Okay, I'll troubleshoot it on the side. But
What does your code look like? Do you mind sharing?
yeah, not quite as clean as yours. Okay, you seeing that?
Yep.
Okay, so I use A and B. I just use the nums. So if num2 equals 0, return 1, that's my base case. Else I assign this variable product to num1 plus multiply num1, num2 minus 1, and return that product. So if I do 7 and 3, I get 22, should be 21. 7, 5.
You're returning
Yeah.
1. You should be returning num1.
Return num1.
Yeah.
Right.
Right.
Should be 35. No, 42.
It should actually return 0 there.
Yeah.
Return 0. Why is that?
Uh, because you have num2 equal to 0. If it was like
Okay,
num2
yeah.
equal to 1, then it'll be num1. Yeah, so just put 0 there and you'll get the 35.
Oh, there we go.
Mm. Yeah, you did a little bit different because of line 2.
Okay, well, solved my problem, so I appreciate it.
The line 5 and line 6 is a little redundant. You don't have to assign it in the value to return it. You could have just done return and then done the functionality there. But that's
Yeah,
fine.
it was just a little bit easier to visualize for me, I guess. But
That's good. I completely agree, right? Going back to the conversation that we had prior, right? It's important to just get some code on the screen to start being able to visualize it. But you know, after once you do get your solution, it's always good to go back and kind of clean it up to make it look nicer. Good stuff. Okay. Let's go ahead and continue forward. So we did recursive mode.py. Different ways to write a recursive function. It's often the case that a recursive function will need extra parameters such as a counter to keep track of which subproblem the function is currently working on. Here's an example. We got if positive is equal to the length of the string, return what you call it, an empty string. They use the POS for the counter essentially. Right? And then increase the counter upwards. The reason they do that, and because sometimes it's gonna be hard unless I show you the description. People are going to try to declare a value within the code, right? And then, or yeah, they're gonna try to declare a value or set a variable, right? Instantiate a variable, and they expect that variable to change with time, but they don't change it in the arguments. So every time their function call calls that the same function itself, it's going to go ahead and declare the same value at the exact same setting. So it's good to, if you're going to set a variable or have some kind of counter, it's set in the arguments. So you can actually increase the counter through the arguments. I've seen where people try to declare a variable within like line 2 and 3, and they think it's going to change by adding, like, for example, if they were to increase the counter of POS +1 within this line right here from 2 and 3, it wouldn't change the next time it calls it. It would keep calling the same function. It would reset the counter back to 0, add the 1, and keeps doing that over and over again. Whereas here, you want to any counter you have, it's being set in the argument area and then being increased in the exact same location. So it follows through with every single recursive call. So just a little food for thought, because I've seen people do it. Student practice listmax.py and it's decreasing.py. Go ahead and try that one out.
Roger, you're on mute, by the way.
Oh, my bad. Thank you for letting me know. Usually it's Cody, but he's struggling today.
Struggling, I am.
Yeah, so we are supposed to create a function, a recursive function that takes in a list and returns the maximum value in the list. You can assume the list contains at least one element, and if multiple elements of the list are tied for the maximum, you would still return that value. So here is our function. We create the function have list and a second argument called current max and set it to none as the default. All right. First and foremost, we check if not list. I don't know why I did this, and we said it says that we can assume it has at least one. But in the event that it was empty, it will return current max. Current element, we create a variable locally within this function where the current element is the first item in our list. And then we compare what our current max is. If current max is none or current element is greater than the current max, then we would set the current max to what the current element is. Or that would be grabbing the very first item in that list and seeing if the current element is greater than our current max or not. Because this is the first time we call it. The current max is none, so obviously it's going to be greater. Current element will be given into current max. Therefore, current max is now the very first item in our list. And then our recursive call is the function itself, but we're only going to grab the number that comes after the very first index. So we essentially slice everything prior to the first one on index 0 and grab everything else afterwards. And then the current max is now set to what we established in the very first call, right? Which is the first index. The next time that this function runs, current max is no longer none. It is now set to the first index that was established on the first recursive call. And then it checks the next item in the list because we got rid of it on the first time we called it. All right, and so keep doing this until it finds the greatest value in this list. And yeah. Oh, and that's why I said this is a base call, right? If not list, eventually the list will be empty as we, go through it and remove items, and then it returns the current max. I know I did it for a reason. Cool. Now, the is decreasing. We are supposed to write a recursive function named is decreasing that takes as its parameter a list of numbers. It should return true if the elements of the list are strictly decreasing, but return false otherwise. Strictly decreasing means that each element is less than the preceding one, not less than or equal. You can assume the array contains at least 2 elements. You were allowed to use default arguments and or helper functions, right? So here we set our base call, which if length of the list is less than 2, then return true, right? That's gonna be the base condition to return our function. We then create a first and second variable, one being the 0 index and one being the first index. We then compare those. It should probably be less than, because we said not less than or equal. We check if first is less than second. And if it's not, then we return false, right? Because that means it's not strictly decreasing. If it passes, well, then we go into our recursive call. We get rid of the first index just like we did before, and then grab everything afterwards. And we keep doing that until we finally reach this part where it's less than 2, right? Which finally calls back everything, closes off our recursive call, and we get our answer. Cool. Did anyone get a different code that they want to demonstrate? No? All right. Well, I believe that was the last item in here. That concluded lesson 12. So we finished searching and recursion. Now we can actually do the regex. Let me make sure it is. Okay. Python regular expressions and ASCII values. All right, well, before we go into this, we're gonna go ahead and take our 10-minute break because I hate stopping once I start. So it is 6:16, come back at 6:26, and we will move forward with the lecture. Yes. So that concluded lesson 12. We're gonna go ahead and move into regex. Regex standing for regular expression and ASCII values. So what is regex? Shorthand for regular expressions. It is a method of searching a string for specific characters. Right? It is used for a multitude of different things like replacing, removing, finding, and matching parts of a string. Quick disclaimer, I have not worked with regex in a while, so I don't remember all the flags. So do bear with me, because I need a refresher myself. But for those of you who end up getting a job working with stuff like regular expressions, jobs like that would be stuff like login screens that take certain input like email address. Typically, by the time you get into a job like that, they already have a standard for how they work with email addresses, so they already have a regex pre-built. But that's where it really comes into play when receiving input from users. In the immersion program, you use a little bit of regex, so it is important to understand regular expressions. This is one of those small things here for data structures and algorithms and whatnot that actually do matter for the immersive program. So if there's anything that you can understand up to this point from this week, is regular expressions. It's going to be used in your backend whenever you create the user authentication or any form of input that you're going to receive from the user. If you want to ensure that they don't input anything into the input box that shouldn't be there, the regex will allow you to make a format for that, right? So you can say whether the email address was invalid or the password that the user inputted was, not to standard. They use regular expressions to filter that. Remember, strings are immutable. When you concatenate strings with the plus equal operator, you are not actually adding things to a string because you can't. Strings are immutable. You're creating a completely new string every time you do that, right? Remember that. This idea applies to regular expressions as well. If you use a regex to remove all the integers from a string, you didn't filter the string, you simply created a new string without any integers. This is a subtle difference, but the concept of immutability in programming is really important. Common case, user validation, right? So how does the computer know whenever you create your little Facebook profile so you can post pictures of your dog? Uh, this is how it uses regular expressions to filter out the input that you give into your application, right? It is pre-built, and whenever you put it in there, it's going to run it through a regular expression, and if it doesn't meet the criteria, it's going to give you an error. Disclaimer, it's only an intro to Python's regular expression module. You're not going to be a subject matter expert. There's so many different things that you can do with regex, but this is going to be enough to get your feet wet and be able to learn more on your own as well. And honestly, this should cover enough for you to feel comfortable to create a regular expression to set in the criteria for an email. There are so many types of emails out there. So it's actually quite complicated trying to filter out specifically what you want. For regex, you're going to use RE, right? You're going to start by importing the RE module, the regular expression module, at the top of your file, right? Import RE. That's going to allow you to use the regular expression methods or functions that come with this module, right? Yes, it's for regular expressions. When using regex on a string with backslashes, just use a raw string. Think F strings, but with the letter R at the beginning, right? So here's a nice little example. So here they wanted to use the backslash, but it was kind of like escaping. So putting the R will allow you to actually use it properly. Python's re.sub module syntax. re.sub is one of the methods that that the regular expression module allows you to use. Does anyone here have any experience with regular expressions at all? I believe it's in your pre-work. Am I correct?
I worked with it in JavaScript, but I have no idea how it works in Python.
Yeah,
Okay.
same. Only in Java.
Cool. So the submodule has a couple parameters. Let's actually go to Python regex. All right, so regex here we have find all, search, split, and sub, and then it has the different types of characters that you use. There's a lot more. For this lesson, I recommend you guys use regex 101, I believe is what it's called. Yeah, this website right here, regex 101, it is money to learning regular expressions. You I don't recommend to build your regular expressions just out of raw code and try to figure out why it's not working. It's always a nice trick to kind of just use one of these websites when you create your regular expressions, so you see what's capturing before you actually put it into your code. So regex 101, bookmark this, have it in your back pocket. It's going to come in handy for the immersive program. All right, so only 3 of the above parameters are required. It's going to be pattern, replace with, and string. The count and the flags are defaulted to 0, but you are able to add them if you wanted to, but they're not needed. If you don't include the count parameter, all instances of the pattern will be replaced. So essentially sub is substitute. So you're replacing it with something. And then here the count, by setting the count, if let's say you want to replace every E in your word with an integer like 0, then you would put the count to figure out how many counts of that is, right? The flag parameter is more advanced, so we won't discuss that. Even I'm not very familiar with flags, so don't worry too much about that. Here is a small example of the sub method from regex. On line 3, we have a string that says, hey, look at this awesome sentence. We use the sub method on line 4. You see here the first parameter is hey, right? So as here, we're trying to get the pattern. The first one is a pattern. What are we trying to find? What pattern within the string are we trying to get? Which is going to be the haze. And then the second argument is replace with. We're going to want to replace it with, it's essentially nothing, right? It's an empty string, open and close quotation marks. There's not even a space between here. We just want to get rid of them. And then this third argument is the string itself that you want to actually filter through. So they use hey, what you want to replace it with, and then the string itself, and they print it out. And we see here, what it prints out is look at this awesome sentence. You might notice that there is a space here, so just be aware that it does capture the space afterwards. There's a way to remove that if you wanted to get it cleanly out of there, but it only grabbed the hey, replace it with open spaces, or no spaces actually, but that last space was still there. Actually, both of these two spaces are still there, which is why it looks a little skewed. And here, we see the exact same string, but what's different here?
You only replace one of them.
Yeah, we want to replace one of them. It still kept that other hey, because we set the count to 1. All right. Here it's because we never changed the default of 0. It grabbed every single instance of hey, where here we only grab the very first one. More sub-module examples, comment non-alpha characters replacing. So here we have the string again. In a weird way, we have apple, banana, kiwi, and melon typed out, but we have some characters that we don't necessarily want. So in our line 4, we use the sub module. We create the pattern that we're trying to find, right? Essentially, if we see this, the open and close brackets is a set of characters. So we try to grab a set of characters. The up caret or the caret, I don't know if there's like an up caret, right caret. Well, the caret is supposed to represent the start of the string. So right here we see starts with. Essentially we're saying, hey, grab a set of characters that start with A through Z lowercase or A through Z capital case, right? So it's grabbing everything that's lowercase or capital that goes from A through Z, right? And then the plus sign here, it means for every instance or more, right? So here, 1 or more occurrences, right? So we want to grab 1 or more of these characters that appear in our string. And that's kind of how it's set. Notice that they put it outside of the bracket, not inside of it. Because we want to grab a set of characters of this. That means if they're together like this APPL, it'll grab the entire one. And if you did it differently, then it will grab multiple of each single character. And I'll show you what that means in a bit. All right, we want to replace it with we call it with empty strings, and then the substring that we put in here, and then we print out the apple, banana, kiwi, melon. I'm actually a little confused here of why this is working this way, because this is supposed to replace. That doesn't make sense. Oh, no.
Is that space after the capital Z? Is that part of it too? So it keeps all the spaces as well?
No, that's not. For space, it's actually something different. Where is it at? Right here. Returns a match where the string contains a white space character. So you use the /S. That will grab the white spaces. Right. So this is the special sequences. Capital A returns a match to the specified character at the beginning of the string. Returns a match for the lowercase b where the specified characters are at the beginning or at the end of a word. And we see the examples here. The ones that you'll use a lot are going to be the D's and the S. So the D's return the match for the string contains digits, or return the match for the string does not contain digits. These are very commonly used. And then what we just saw here from A to Z, you can do that as well with this. Return the match for the string contains actually no, that's here, the W. Return the match where the string contains any word characters from A to Z, digits from 0 to 9, and the underscore characters. This is a very common one as well. You could do that with it as well. Those are special sequences. Here we have the sets. The A through Z, 0 to 5, 0 to 9. The ones that are commonly used are these specifically, and the 0 to 9 as well. Right? I am not gonna lie to you, I'm a little confused of why it's doing that, because if it's supposed to remove it, I don't know why it's printed out in this manner, because it's supposed to grab everything that's lowercase or capitalized and replace it with a space. So
What's going on is when the caret's inside the square brackets, it says anything that's not a letter, lowercase a to z or capital A to z. So if the caret was, if the caret was outside the square brackets, then it would say if A to Z is the first character. But when it's inside the square brackets, it says anything that's not a letter. So that's why it replaces those
okay, that makes sense.
characters.
Right here. Return the match for any character except A, R, and N. So you're absolutely right, Mikhail. Man, you're a genius, dude. Anything that isn't this, right? So that's why I was confused. I'm like, this doesn't make sense, because if this was what I thought it was, it would have replaced the A through Z's characters with nothing, right? But awesome, good observation there, Mikhail. See, this is why you gotta come to class, man. Let's see. Are we recording? I want to make sure we are. Okay, we are. Good. But yeah, good stuff. Good observation. Here is the exact same chart that we saw in the W3 schools. The open and close parentheses grabs a set of characters. Backward slash signals a special sequence. All right, and it's also able to use for to escape special characters, and we'll talk about that in a bit. All right, so special sequences are like the lowercase d, the W, the S. Those are special sequences. And when it means about escaping special characters, let's say you want to type in like the @ symbol. You want to be able to grab the @ symbol. If you just put the @ symbol sometimes, unless you use the backward slash, it won't recognize that that's what you're trying to do. So using the backward slash allows you to escape special characters, or like for the quotation marks. If you're trying to grab the quotation mark within the regex, sometimes that helps. The dot is any character except new line character, right? So that will grab everything that belongs to that. So it'll grab all those. The caret starts with, but as we just saw, also if you put it within the bracket, it'll grab everything except what's in here. So different way of using it. The money sign ends with the asterisk 0 or more occurrences, the plus sign for 1 or more occurrences, right? There's a difference between these, so make sure you use which one wisely. 0 or 1 occurrence for the question mark. I haven't used that too often. Here we have curly brackets, which is different than the square brackets. Exactly the specified number of occurrences, right? So here we see 2, right? So we want to grab a pattern, a word with this pattern where it starts with HE, and then we want to grab anything that could be either a number, a word, a space, as long as not a new line character, right? If you remember here from what the dot says, except new line character, but only 2 of those, right? So let's say there's a word that has hello with 4 L's, right? Because they want to be cute, right? You know, when you're texting your partner, you're like, hello, you know. You try to grab that message, but you only want to grab the first two occurrences or whatever it may be. That's how that works, right? So curly brackets, so two of whatever we capture from the period, and then O, right? This is the pattern that we're looking for. The pipes, very similar to JavaScript, is either or, right? How we use the and or in JavaScript, falls or stays. And then we have the open and close parentheses, which is capture and group. And we'll talk a little bit more about grouping in a bit. Example of some meta characters, right? So here we have a string that says learn to program because programming is cool. We want to substitute the pattern that says just program. We're specifying specifically the word that we want to get, which is program. We want to replace it with dance. All right, and then we want the string that we want to filter through is through some string. And we see here it goes from learn to dance because dance mean is cool. Notice how, first of all, we didn't set a count here, right? So when we ran the substitute method, it grabbed every occurrence of program within the string and even grabbed it from the word programming, right? If we would have put count 1, it would have just replaced the first one, but then it still would be a weird string because we never fixed programming. And then over here, we actually have a better example of that. We have the exact same string. We put what we want to get, which is program, and then we put a question here, which if you remember, it's 0 or 1 occurrence of main, right? So that means there's option, right? If it has main in it at the end of it, then grab it. If not, it's okay, right? So that means it will still grab the program one because it doesn't have it, so it will still grab that one. But in the event that we do have one that ends in main, then it's going to grab that as well, and just those specifically, right? And then same thing like before, dance, and then the some string, and then it effectively grabs dance and replace it. So learn to dance because dance is cool. All right, so that's a little bit better than the first one. And we saw how we were able to grab that depending on an optional condition using the question mark. You can also pass a function, right? So here we have the function called replace. It takes an argument called match. And match is I want to say it's a string. Group 0. I haven't worked much with the functions. So let's check out the group one. Group. The group one isn't here. Python regex group. I'm not the biggest fan of the documents for Python because they're not as friendly. Whatever. Right, so the doc group typically grabs stuff in pairs. We put 0 is equal to programming, right? So the way it works is whenever you're grabbing groups, right, using the open and close parentheses, it's gonna actually almost like create a list of all the groups that you found that share that, right? And because it's a list, they're using the index notation here for 0. It wants to grab if the first one that we grab is programming, then we want to return that, and else return that. So if that group, that first group of 0 is has programming, they return dancing. If not, return dance. So here, we have learn to program because programming is cool. The match, if I'm correct, is going to go through it and look for within this group for any instance that has programming. So we have to learn to program because programming is cool. The same code that we had before where we grab program in the main optional. And then replace some string. Here's a pattern that we're sending it. We're actually passing in the method as the pattern. So it runs the method whenever it runs the sub, and it checks whether it's programming or just program. All right, and then it formats the string for you. I myself don't have too much experience working with using the function itself. I never had to use the function, but as you can see, it is an option. So I won't speak too much about this one because I myself haven't really messed with it too much. An example of the flags parameter. Let's look at the flags because I don't have much Spanish flags either. Go to sub. Man, they really don't have much on this one. All right, so we have hey you, yeah you, I love to code. For the substitute, we're using the pipes to grab options, right? So it's either I or love or to code. So either or, and we want to replace it with ski. And then we pass into some string. It doesn't do that. Why? Well, because it's lowercase, right? It's going to take the pattern specifically of how you actually pass it in. And here it's all lowercase. So it's not going to grab anything from I love to code because it doesn't match it, right? And the flag ones, it has a flag where you're able to ignore specific cases, which is the ignore case. There's more flags than just this one, but I don't use these often. And it replaces every single instance with ski because it found it has the option to find all 4 of these words within the string. Use the flags to let it know, hey, I get it. It's all capitalized, but it does not matter. Ignore the case and it replaces it with that. So if you want to do more research on what flags are for each one, you can. Python sub flags. I want to find it so we can talk about it. Flags. Here we go. So we have ignore case, performs case insensitive matching expressions like either they will also match lowercase letters, locale, case insensitive matching dependent on the current locale. This flag can be used only with byte patterns, multi-line, no flag, dot all, make the dot special character match any character at all, including a new line. Without the slide, the dot will match anything except in one. So we're able to change the dot one. Unicode, verbose, compile. No, that's the whole method. That's not a flag. But yeah, so you see there's other flags you can use. I haven't needed to use any of these, but it is optional. So there's the flag ones. The dot replace versus the dot submodule. Right, the submodule is more versatile than the built-in dot replace method. Pro tip: forget the dot replace and master the sub. Regex, man, regex is phenomenal. Right, it is a skill that if you learn, it replaces a lot of stuff. Like for example, the dot replace method, because you're able to do the exact same functionality, but you have more things to work with. Right. With the fact that it's a regular expression, you have all these different parameters you can give it to be more specific with what you're looking for. right? The dot replace, as you see here, it's going to grab one word and replace it with what you want. It takes the word you want and the one you want to replace it with. But with the dot sum module, you're able to just specify the type of word you're looking for and be able to give it different conditions depending it has an optional ending to it. If that word you're trying to replace has characters in it that you don't want, dot sub gives you that versatility that the dot replace does not. The find all. It scans the string from left to right, searching for all non-overlapping matches of the pattern or string that is passed in, and returns a list of matches. Right. Here's kind of an example of what I was talking about when it returns stuff to you in a list. This is the first instance you'll see of it. Here we have the find all, and we're looking for all instances of you. And then it returns to you those instances. There's actually a way as well to see the index of these. I just can't think of it from the top of my head. But it'll grab every single instance for you and return the list of matches. Find characters in a set. All right, so finding all, here we want to grab a group of characters from A through E through some string, and it returns to you the list of all those. Find integers in a string, like those special characters that I mentioned, the lowercase d, very helpful and very commonly used to find all integers. If you guys remember, where is my, here it is. Lowercase d returns a match where the string contains digits from 0 through 9, right? So it finds all those and returns to you in a list as well. The more special characters we discussed, the dot, the lowercase d, and capitalized, right? For either if you want to grab everything that's a digit or that's not a digit, you could do that. This is essentially replacing this. So if you use the lowercase d, you don't have to do 0 to 9 because it grabs all those. This is the same as this as well. With a caret, the lowercase space match a white space character. So like the N, that's a new line character. I'm not too familiar with the R, T, or F. I don't ever use those. I want to say T is probably tab. I don't know what R is or F. But for all white space characters, and then you have for the non-white space characters, now we learn things from Kel. The caret within the brackets means anything that's not this, right? W match a single word character. So here it's the same as getting A through Z, capitalized, lowercase, or any kind of digit, and even the underscore. And then same concept for the capitalized W, it will be the same as this with the caret. Find a particular sequence. Find a sequence that starts with he, followed by any two characters and an O, right? So so here we have a pattern where we're trying to find hello, or it could be anything that doesn't have the hello, right? So we have the heyo, hebo, and hekio. It's gonna grab the first three because we're saying, hey, two instances of whatever character, whether it's a digit, a letter, or an underscore, only two instances. And you guys remember to the previous example, after we put a dot, we specified as well how many of those we could find. It's the same as using the curly brackets, they put two. Well, here, instead of doing that, you can just put two of those as well. Same thing, and then ending with an O. So the reason why it doesn't grab hekio is because there's three characters between the E and the O, where here we're trying to grab where HE and O only have two characters between it. So it does not grab the last word. Find all example. We covered just a few to show you what is possible. Here we have A through Z, one or more occurrence of A through Z. It's going to grab hello or world. and then we want to grab it from the string to match, which is hello world, right? It returns a list because we're using the find all method. Right, we don't have to specify a count here because we have the square brackets. So there's no specific. Also, because the plus sign is gonna grab more than just one word, it grabs these two right here. Find iter returns an iterable with every match object. Here's what I'm talking about. Here we have hello, yellow, fellow, hello, Menlo. Right. We want to grab anything that says hello from some string. And it gives us a span, right? It tells us from where it starts and where it ends. For the first hello, it occurs at index 0, 1, 2, 3, 4, and up to index 5, right? If you guys are usually when we use stuff like range, it's up to, but not including that second number. So it starts at 0 and up to index 5, not including index 5, but up to, right? That's where hello is at. And the second time we find hello, it's at index 11 is where it starts, up to index 24. So I knew there was a way to find the locations of it. So the find iterable with every match object. Notice that on line 6, they do for match in matches. Why? Well, because it returns a list of this, right? Very similar to the find all that it returns a list to you of all the matches it did. It's going to do the exact same thing for you. So if you want to grab every single one, you have to loop through it. If you try to print just matches, it's going to give you a whole list of this, and you might be surprised how long it's going to give you. Right? So it is a list, so they loop through it and printed every single one of them. Match returns the match object only if it's first in the string. Here we have yellow, fellow, hello, Menlo. We're looking for hello. And because it didn't find it at the beginning of the string, it got nothing, right? So it prints none. Whereas here on this code, it's at the very beginning of the string, it grabs that match and returns it for you. I don't know, there should be a flag for this one. But yeah. Dot search returns the first match object in the string. So it doesn't matter if it's at the start of the string, it does not matter wherever it may be, it'll return you the very first one. It searches for hello, it prints it out for you if you wanted to, with the index location. So start at 14 and at 19, it'll tell you where it's at. It doesn't matter if it's start or not. So very similar to match, but this one is not just the start of it, it's anywhere within that string. All right, we see two different ones of these. Keep in mind it's the first occurrence, right? So he grabs that first hello, but not that second one. Dot split splits the string by using the pattern as the delimiter and returns a list. So here we split it at the @ symbol, and it returns you the list of every single item from the string that was split within there. Delimiter is just another word for like to express what's going to separate your strings, right? We saw it in CSV files. In the CSV files, you can specify a delimiter that you want to use. The delimiter here is going to be the @ symbol. So it splits it, and we print matches. It returns to you a list. It prints out the entire list with the words that were split with the @ symbol. At the @ symbol. Match object utility. All right, so getting the indices of the string matches. So here we specify the dot span method, right? So if you remember from the find iterable, we can find the every single time it occurs as well as the span. Right? It printed out the object match, the match itself, and then the location of it. Well, if you only want to grab the location of it, you can specify the dot span method, and it'll return to you just that. So grab every single match within the matches list and just the span itself. It'll tell you the 14, 19 of hello, and then 26 and 31. I know this is like a final information, and we're just going through these really quickly. You don't have to memorize these, right? Don't feel like you have to memorize these. Like I mentioned before, a lot of stuff that we do is perishable, so you're not expected to memorize this. Like we're not computers, right? We're gonna be software engineers, software developers, and as long as you know how to find the answer and you've been exposed to before, it should be something that you can easily find later on in life. So we got a span. We're able to get the start and the end. Same thing here. The span itself is a essentially a tuple of 14 and 19. But if you want to specify which one you grab, whether it's the start and the end, you can do that as well. Match object utility, get groups for individual matches. It'll be important later. I don't remember where later. But here we find every time that hello is iterated through our string, and as mentioned before, it's a list. And we use the dot group method, right? Because the way that it works was that it returns to you a group, and this is the group itself, right? This is how it looks like. If you just want to grab the item within that group, you can do the dot group method, print out for you. Exact numbers and ranges. Given a specified number of characters in your world. So here we have a string. We're trying to find every time it was iterated through here, anything that was a digit of 4 occurrences, right? So 4 occurrences of a number, and it returns to you the match of 1, 2, 4, 5. This is the only one that had 4 different digits occurred back to back 4 different times. It does not grab the 14 because it did not meet the criteria from the regular expression, right? And then we have the 3 to 5. This one, if I'm correct, is you want to get up to 3 or to 5, no more of occurrences of that number, right? Still does not grab the 14. So we'll do one example before we move on. Vowels and domains stop high. Go ahead and attempt that. Use that regex 101 example website. That's gonna help you out a lot. All right, let's go ahead and talk through this. Share my screen. So I am a firm believer of this website. I absolutely love it. So what I like to do is I like to get the string that I'm trying to filter through, right? In this situation, for the vowels in domain.py, we have an input text that says errors should never pass silently unless explicitly silenced, right? And we want to write a function that uses a regular expression to return a list with all the words that start with a vowel. So first and foremost, you want to switch this to Python. And then function is going to be list, right? So we're going to want to, I believe we want to work here. I've never used a list function. I usually just use the one up here, but let's try this one down here. So we want to grab words that start with a vowel. So opening close brackets is going to allow us to grab groups of vowels. We want to specify specifically either it's not gonna be A through Z, it's gonna be A, E, I, O, U. Or A, E, I, O, U, I believe. It's not working here. Let's see. Let's see if we do it over here. Well, it's working here. Don't matter. The listing doesn't really matter. Let's go ahead and just use this because we can start seeing some actual input here. So now we see it's grabbing all the vowels within here, whether they're lowercase or capital case. But we know that we want to grab the start of it. Well, how do we do for the start? If we go back here, we see that we have the B. All right, lowercase b returns a match where the specified characters are at the end or at the beginning or at the end of a word, right? So let's try that out here. If we use the /b outside of the brackets, then we know it's going to grab everything that starts with a vowel from lowercase or capital case, as long as it starts with it. And we see that it's grabbing the errors, unless, and explicitly, but just grabbing the first letter, right? So after we grab the word that starts with A, E, I, O, U, lowercase or capital case, then you want to grab obviously every word or every letter that comes afterwards, right? So we're going to do A through Z, lowercase, and then A through Z, capital case. And we're going to do the asterisk because let's look at that. Okay. We have 0 or more occurrences or 1 or more occurrences. Because what if we have like the word a, like a guy, right? Well, sometimes it might have a 1, so we want to grab it if it's 0 or more. Because, oh, I mean, I guess we could also do the plus sign. Plus sign or not, we'll use the asterisk. That should be fine. And that'll grab the entire word. And then we want to, just to ensure we do this deliberately, let's also specify that it ends with this. I believe we put it at the end. It'll grab the ending of it, right? So here we have, they have the /b before it and then afterwards. So we want to ensure that it grabs the vowels to start with, and then it ends with anything between A through Z, lowercase or capital case, at the end of it. And it should grab errors unless and explicitly, right? Well, now let's actually look at the code. What it's going to look like. Let me go ahead and minimize the other one so you guys don't see this yet. So we create our pattern, right? So now that we have that pattern, we're able to create that value called pattern. Use R for for the regex, and then open and close quotation marks, and then we actually copy and paste our pattern within here. That makes our pattern for us. Then we can create another variable called result where we start the regular expression. We're going to use find all because we know that find all returns not only every single instance of it, but it also returns a list just like it's been asking for us. We add the pattern that we created in here as the first variable, and then the second variable is going to be the string that we're actually trying to filter through, and then return result. And it should return errors unless explicitly, just like we declared it. Cool. All right. Next is going to
real quick.
Yes.
Sorry, could you explain why you needed the /b at the end again?
Yeah.
I was just trying to look at it.
Right. When we go here to special sequences, we see the different types of characters we can use. We have the backwards /b, and it returns a match where the specified characters are at the end or at the beginning. So here we see the example of when it's placed at the beginning. So this will return any AIN letters where it starts at the beginning, right? Because they put it there at the beginning. But when it plays on the right side, it gets it to you whenever it ends with AIN, right? So when it plays on the right, it grabs the word if it's ending with that. When it plays on the left, it grabs the word when it's beginning with that, right? We want it to begin with A-E-I-O-U. It doesn't really, I don't think it will make a difference if we don't do it at the end. But just for good measure, it don't matter.
Oh, so that the last /B is the end for the A to Z. Okay.
Correct.
All right, I'm tracking. I was confused on that. Okay, I got it. Thank
We see here
Yeah.
that it doesn't really make too much of a difference because the one that really mattered was for it to start with the vowels, right? So for sure, the left one is needed. I just added it for good measure. No biggie. Still got the same result. Cool. Anybody else? Comments, questions? Okay. All right. Next is gonna be the email, right? This is very simple. There are more complex emails, right? We have emails that consist of underscores, digits. We have some that have .mil at mail.mil, as you guys are familiar with as well, for the military dudes, right? So all types of emails, but for simplicity purposes, we have it this simple. So who wants to walk me through it? How do we grab the first item? Anybody?
You would do brackets, $, at symbol. So we're trying to, what I was going for, I was trying to capture where the at symbol was, and then I did the $, because I want to get what's after the at symbol, not what's before.
You can. That is one way of doing it. If you have it, we'll work with it. So yeah, so we want to ensure that we grab. We see here it's letters, so anything between A through Z. It'll grab that. We want to begin with that, so we can put it in the start, and then maybe put. We want to have at least one occurrence, so the asterisk wouldn't work here, right? We want to use the plus sign, because it should have to be before the at symbol. So we want a plus sign for at least one occurrence of it. So definitely the plus sign. We see here it's grabbing everything except the at. But after this, it should be able to grab the at symbol. And because the way that it's formatted here, we're saying, hey, our expression needs to consist of letters A through Z to start, and then right afterwards, it has to have the at symbol, right? Because this is how we're establishing our pattern. So you don't exactly have to have the money sign, because of the way we structured our regular expression, it should still capture it, right? So it would be the at symbol afterwards, and then we want to grab another occurrence of A through Z. At least one occurrence of it, followed by the dot, and then followed by A through Z again. One or more occurrences. Because I don't know how many are out there. Oh, I mean, we have like, what would you say? At abc.com. .net. Are there .net emails out there anymore? Or .aol? I don't know. There, just for the sake of it, at least once after the dot, right? And we see here it captured it effectively. To be a little bit more specific, we can do A through Z capital as well. Actually, it would make more sense if we just use the W, because sometimes we want to get underscores as well, because there's emails with underscores. So maybe even using W would just be just as effective, right? Actually, for this one, maybe it's better if we just do A through Z. Because I don't know there's underscores after the at symbol. There we go. But yeah, so it's grabbing the matches. And that should work efficiently. I don't know why mine's not updated. I don't know what I was doing here. But we can essentially just replace this. All right, this is our regular expression. It starts with anything with the letter, lowercase or capital case, as well as underscores, one or more occurrences, and then it's gonna grab the at symbol. And then we can actually, for the sake of actually seeing our stuff, let's go into what is lesson 13. Oh, Python vowels. Can't find main. What are you talking about, dude? Probably.
You still have to CD into the val or the
Oh, thank you. Here. Oh, Python vowels. Okay. Okay. This is grabbing not what we're looking for. So it's grabbing the first one worked. Errors unless and explicitly. Let's go ahead and would that work? Why was it not working?
I mean,
Oh,
you
my
still have your
bad.
Facebook
That's
feed.
why. Okay. I didn't even understand the assignment. So right after that, use to return a list of emails that all have the domain of Gmail. My apologies. Man, I did this wrong. At and then it should just be Gmail. .com. Why is it not working? Am I tripping? Oh, it replaces it. My bad. Man, that's what I get for not looking at the assignments. We want to replace the pattern with Gmail, so we're looking for anything that has at and then A through Z, and then one or more occurrences. There we go. My bad. Sorry, boys. There you go. I misunderstood. I wasn't even looking at the assignment or reading it. And when you're solving it, you're probably just confused. And no one said anything. No one said, y'all just stood quiet and watched me do this on camera. Am I even recording? I hope I am. I am. Okay, good. Yeah, so we were replacing it, substituting the pattern with at Gmail. It got it, and then it returned it for us. Pretty straightforward. Cool. All right. Time is. We just got back from break. Man, I'm all over the place, bro. Okay, so that takes care of your vowels and domains. Moving forward, capture groups. A way to treat multiple characters as a single unit. Here we have the string hello 1 2 3 4 5 pound 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 sign or hashtag, whatever you want to call it. And then we're finding a list right interval and to return if we didn't specify the group, it would return a list, right? And here we in our pattern we have 3 different sections wrapped around in parentheses, right? We're essentially establishing groups here. The first group is going to grab anything with A through Z, lowercase or capital cases, more than one occurrence. Second one is any digit, one or more occurrences, and then anything that's not a digit, one or more occurrences, if I remember the capital B correctly. Return match the string does not contain digits. Okay. We go through the matches and we print out complete string. Matches the first one, the match group 0, right? That prints out the entirety of it. And then we're actually going to work through the regex 101 right now in a bit. The first string itself is the first match, second match, and the special characters is the third match. So let's check that out. Let's go to our regex. It's going to be hello 1 2 3 4 hashtag. Did I do that correctly? Yeah. We're gonna do. Can we do match? Actually, it should be fine. Matches Python. The first one is A through Z. So we're gonna grab A through Z. Plus more. Yep. Okay. All right. I'll show you why it looks the way that it looks. A through Z. One more occurrences, and then we want to grab 0 through 9. One or more occurrences, and then we want to grab capital B, one more occurrences, right? So what the parentheses does, it matches stuff into groups, right? It is going to return to you 4 different groups. Why? Well, the first one is going to be the first match itself. It's going to be the entirety of the string, right? It's the hello 1 2 3 4. So when you get this, it's a list, but the first index will have the entirety of the string, which is why they use the match.group 0. The next one in that list is going to be group 1, right? The very first group that you created, right? First capturing group, the first parentheses. And we captured the regular string A through Z, capital case or lowercase. We print out that one as well, right, on group 1. The second group is numbers, and the third group is the special characters, right? That's how that works, the grouping. The first one is the entire of the string, and then afterwards, it's the groups according to how you grab them. All right, does that make sense? That's how it's going to return to you in the list, which is why it's in this index. Regex practice.py. Give that a try. Share. Okay, so we're doing one by one. The first one was to write a function that uses a reg expression to return true is a boolean is a string that is passing contains only upper and lowercase letters. Okay. Well, it would make no sense to use regex 101. I might as well just talk through it. So we create the function called is alphanumeric. Can you guys see my screen? Good. We create a string and we created our regex expression. We want to see if it contains only upper and lowercase letters and underscores, right? So essentially this would return false. Why would it return false?
Because the
Because it
spaces.
doesn't have an underscore.
Because the space is correct, right? This will return false, and this should return true. So the array expression goes as follows. We use the brackets because we're trying to grab a set of characters. We want to grab A through Z, lowercase, capital case, uh 0 to 9 and underscore. What's another way we could have written this?
Slash W.
Yeah, the \w, right? The lowercase one. After we use that, we use the plus for one or more occurrences. And we use the up caret and the dollar sign, pretty much just saying to for it to be one single word. And this essentially returns false because it's multiple words separated with spaces, right? We want it to be underscores. So when we run this, um, the first one, which is using string one, will return false because of the spaces, and the second one returns true due to the fact that it's only uppercase, lowercase numbers, and the underscores is what's being used to separate our words, right? Pretty straightforward. We use the match, so we can match the pattern with it, and the bool will return to you true or false for the result, depending on what match returned, right? Hopefully you guys all came to the same conclusion as well. Do you guys use bool as well? Anyone do that differently? Okay, cool.
I just used an if statement. If
Okay.
R dot match 5 my string, return true, else return false.
Okay. Yeah. I didn't know I could do this either until the first time I did this, I was like looking up how to do it, and I came to this. So you can use the bool and it'll turn true or false if it matches the string or not. So that
I
is an option.
also use the ignore case flag, so I don't have to do the uppercase A to Z.
Okay, that's a good way too. Yeah, good stuff. So the ignore case flag is an option. Yep. Awesome. Anyone else do something different? Cool, cool. Yeah, good job, Mikkel. That is an option. Next one is going to be to write a function that uses a regular expression to return the Boolean true if the string that is passed in starts with the number 5. This one was pretty straightforward. We just want to grab the 5. We use the caret to let it know that it's one to start with. Or essentially, you could have also used, I believe, the \d. That should still return to you the 5, right? We have two different ones, the 6 and the 5. We can go ahead and uncomment this out. And obviously the first one will return false because it starts with a 6, and the second one will return true because this one actually grabs the one with a 5. Cool, cool. Same concept as the first one, we use the match one as well, and the bool to give us true or false, depending on what the result brings back. These are didn't make it some examples, but for number 3, we have to write a function that uses a regular expression to return Boolean true if the string that is passed in has a number at the end. This one, straightforward. The D, if you guys remember correctly, is for a match where the string contains digits, numbers 0 through 9. So we use the lowercase d, the dollar sign for it to be to end. I believe we can also use the /b here. Either or should work. Right, ends with, that works as well. So the dollar sign, it searches for it, and using the search will return to the list. Not the list, it will return true or false, my bad. Cool, cool. Search pattern result with the bool. Next will be the write function that uses write expression to return a list of all the instances of a dog or dogs. Here we use the pipe for or, so either or. I forgot what I did this for. What did I use this for? I forgot. It's been a while since I've seen this. Which one was? Sorry, I haven't touched this in a hot minute. Well, we want to grab dog or dogs. I don't think uh we really need any of these two. It's been a while since I've done this myself. Go ahead and try it out. France, find dogs, and then we'll use this. Let's try it out. Dog, 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 dog. Let's see if we use
This is what I spent most of the time on trying to fix too. I fixed it just by putting dogs first and then dog.
dun, 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 na, 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 na. Okay, I think that's why I use this. Dog, dog, dogs. Oh, I think if we do dog and then S question mark. Oh. No, we should be able to do dog, dogs. Get the space. How did that work? Let's check it out.
This one was the one that was tripping me up the most too. I fixed it just by putting dogs first, the plural, and then dog after.
It's been a while since I
between
did
a
this
pipe.
myself, so it's okay. No biggie. You said how you do it?
Just I used the pipe and then put dogs first, the plural, and then dog after, and it worked.
And that we're using which one? The find all. Insert. It should be able to do dog and then
And then the F's, yeah, it wouldn't work for me for some reason.
yeah, it's confusing. List. No, we should be able to do match. Dog. Oh, my bad. Put this rotation mark. One more percentage. Why is it not working? No. That's so weird. Dog
Right.
or dogs?
No,
This
dogs
should work.
first. The plural first works for me.
Why do you think that is?
I have no idea. If I didn't put the plural first, then it would just capture all dog and it wouldn't capture dogs.
Who came up with a solution? Anybody? Match. How did I come up with this one? Flower dogs start with or end with. It should be dogs with this. Yo, I am tripping. Who came up with a solution besides Joseph? No one? Oh man, Neo was stuck in his entire time. First capturing group. But why is he not capturing more? That's what I'm confused about. Dogs. That is so weird. All right, so let's look at it, right? Signals is special signals that characters, any character starts with exactly the specified number of recurrences, capturing group. Yeah, we want to do dog. And then multiple. Yeah, but here we're so I'm using a plus. Matches the previous token between 1 and unlimited times as many times as possible. Giving back as many, but it's not doing that. That's so confusing.
I'm not familiar with this too much, but does it matter if you have match or list on the left there?
I believe so.
Yeah, never mind.
Let's check it out. That's a replacement value here. List. I don't think the list is gonna do. We want to match. Want to grab everything that has dog, but it's not capturing the other stuff. First capturing group. It should just be dog. Mikhail, use your brains here. Anything? And to start with dog. Why did this one work? I have the. Let's check it out here. Actually, it might actually tell us here. Dog or dogs. Okay. It's not working here. Would they work here? Find dogs. And put the string. Print. Dogs. It's working. Why? We have this question mark. Let's check out the question mark. The question mark does 0 or 1 occurrences. And then what is the colon? How did I come up with a solution this time? Here, let's see, the colons are here. No, it's not here. I don't know how the heck I came up with a solution. But the colon works. 0 more occurrences of dog or dogs. But if we get rid of the bees, it should still work. right? No. Yo, what in the heck is going on? Yo, I do not know what's going on. I don't remember how I came up with the solution. I'll try to do more research on this, but just know that it works. That's so confusing. I don't know how the heck I found this last time. Python, regex. No, I'm not sure. I'll figure it out. When I find an answer, we can talk about it. I think I just saw someone talk about it here. Yeah, I'm not quite sure. I'm not gonna waste too much time because we don't have too much time to spare. But you know that this one worked. Capturing this was 0 more recurrence. I just don't remember what the heck the colon was doing. Was it pretty much saying 0 more occurrences of what follows after the colon? Maybe, but it wasn't working how it should be working, where it was using the plus or the asterisk. That's what really confuses me. That should have worked, but it didn't, and I wonder why. But we'll keep moving forward. The next one was to write a function that uses a regular expression to return a list that only includes the numbers. So we want to get 10, 20, and 30. That one was pretty straightforward. The digit one was what we wanted to use. Plus for 0 or I'm sorry, 1 or more occurrence of it. And that should return to us the list of it all. I don't think we need the factor slashes, but extract numbers. Let's go ahead and give it this. 10, 20, 30. Let's get rid of the B's. 10, 20, 30. Yep, it still does it. All right, that one was pretty simple. You don't need the B's, but you should still use the lowercase d. That'll grab you from 0 to 9. It grabs just those. All right. We'll keep it here. We're gonna stop the recording and